Hello and welcome to the next episode of Differential Equation. We will continue from where we have left. This new video is to make you aware and make you understand a little bit more details in what is called an order and a degree of differential equation. Okay, so in order to know that what is the definition of a degree and an order, what we are going to do is I'm going to give you a very quick revision on the earlier video, just a quick note on the topics that we have covered. Now, if you have missed my earlier video, you need to note that few important points that we have covered earlier. This one, that what is basically a equation. We have covered this. What is what are the exponents, coefficient, constants? Too elementary, but this is the first thing which we have done. Second is that we have covered what are the different types of equation. So we have seen what is a linear equation, we have seen what is a quadratic, what is a cubic, what is an inverse, and what is a differential equation. Although we have given examples of how a linear equation can be plotted and you get a graph on that. Third is that what we have done is that we have covered the notations of differential equation. We have covered Leibniz, Lagrange, Euler and Newton, and the different formats. You can see that each of them has different formats of using it, and what is the advantage of using these four differential equation notations. So you can watch out my earlier video on that. Lastly, what we have done is that we have seen what is a differential equation, and we have seen the two broad categories of differential equation, and we have seen that differential equation can be divided into ordinary and partial, PDE, and ordinary equation can be linear, separable, homogeneous and exact. Although here we have not covered the homogeneous part, but we have seen more or less the examples of what linear, separable and an exact differential equation is. So this is just a basic overview in order to make you understand about what are the things we have covered earlier. So here is the video in which we are going to learn about the order and degree of differential equation. So in order to, first we will look into order, which is a pretty straightforward way in order to understand. So what we are going to do is that I will just show you a quick definition of what is called an order. So order of a differential equation is the order of the highest derivative, which is also known as differential coefficient, present in the equation. So I repeat, it is the highest derivative known as the differential coefficient which is present in the equation. Few quick examples will make things easier, will make our life easier. So in order to know that what is order of a differential equation, so what we are going to do is that I'm just going to write few equations, and it is quite simple. I think it will be a very intuitive approach through which you can understand. So my first equation to know order would be dy by dx minus cos x equals to 0. Right? So this is my first equation. So what is the highest order? Order means to the power. It has got no power. That means this is order 1. Right? We can take another example. This is my first one. So let me see another example. I can write xy d squared y by dx squared plus x of dy by dx, I would make a whole squared, right, minus y, and I can use dy by dx equals to 0. So in this case, if I use a red pen, it becomes easier for you. So what is the order? So so you see that you need to note the definition that we have given. So what was the definition? The definition showed that it is of the highest order, right? The order of the differential equation is the order of the highest derivative. So which is the highest derivative over here? This one. So what is the order? Order is 2. So it is pretty intuitive approach and it becomes clear. So let me give you another example. So more we do with the examples, it becomes clear. So we have used the prime notation. We have learned it earlier that we use Lagrange's prime notation. So we write y, and these are 3 primes. And then I use y squared plus ey prime equals to 0. If this is my equation, so what is the highest order? 1, 2, 3. So the order is 3. So I write order 3, right? Let me take another example. So I use d2y by dx2 plus 6y equals to 0, right? So what is the highest? This one. So again, order is 2. Let me give you another example. So d3y plus dx3 plus x squared, and then I can put further like d squared y dx squared whole to the power 3 equals to 0. So you see what is the highest order here? So this one raised to the power this or this one. So you need to look at the what you have to look, order of a differential equation is the order of the highest derivative, highest derivation. So this is which one is the highest? This one. So order is 3, right? So using that part, we can use further few examples which will make things easier. I can write like this. So let us see another example. X dy by dx plus I use a trigonometric function sine of dy by dx. Although this is not, I will say you later, this is not the right way in which you can get the partial equals to 0, right? So what is the order? If it is nothing, this is this one. So order is 1, right? Further example, let me show you. I can say d3y divided by dx3 plus y. Then I do dy by dx, right, equals to 0. Which is the highest one? This one, order 3. Okay. Now you might be okay, fine. This is one. Okay, so now we see another example. We use d3y divided by dx3, and I use d squared y dx squared whole squared plus y equals to 0. If this is my differential equation, what is the order? Now, a few people might be wondering what is written over here, this part. Now, I can, this if I want to solve it, say algebraically, I can use d4y squared by d squared x4. Isn't it? Then I get what? I get the partial derivative, the highest derivative as d4. And if you say that your order is 4, it is going to be wrong. This is not the way in which you should do. This is a second order derivative of whatever. It can be a equation, a coefficient, whatever, and it is square of that. So this is not the way. So what is the highest order? This one. So the order is 3. Clear? So you cannot just make a square and find out the exponent as 4 and then you can say. This is basically the second order derivative. So whatever it is a square of that value, right? So this is quite a simple way. What you need to do is just look at the power and you need to find out which is of the highest power, and this is what we call as an order, right? Now we will go to the last part, which is the most important part, and we will see what is called a degree of a differential equation. Now before that, I would like to show you this. The very basic definition. Just pay attention to the first part. Degree of a differential equation is represented by the highest order derivative in the given differential equation. The differential equation must be polynomial equation. Right. So what we are saying here, the degree of a differential equation which is represented by the highest order derivative in the given differential equation, and the differential equation must be a polynomial equation. Now, if I consider those who are not quite aware about what is a polynomial equation, here is my definition. The equations formed with variables, components, exponents, coefficients are called polynomial equation. So you can just write anything like this. So from here what we can do is that if I just want to write a kind of a polynomial equation, I can write like 3x squared plus 5x cube plus 4x minus 2x4 plus 9 equals to 0. It can be a polynomial equation, right? Because it is formed with variables x, x, x. It has got exponents. These are the exponents. Coefficients are there, and it is called a polynomial equation. Now, before we move, so this is, you need to understand that in order to find out a degree of a polynomial, degree of a differential equation, the first condition is that differential equation has to be a polynomial. The differential equation has to be a polynomial. And what is a polynomial? This is a polynomial. It is formed with variables, exponents, coefficient, which is called a polynomial equation. We'll come to this part a little bit later. But what I would like to show you a little bit different. Now, polynomial equation can be further divided into these parts: monomial, binomial, trinomial, linear, quadratic, and cubic. I will just take 1 minute time and I will just explain quickly what are those things. Monomial, which has got only one variable. So we can write monomial equation as ax plus b equals to 0. It can be x plus c equals to 0, doesn't matter. Okay, binomial equation, which has got two variables. So I can just write quickly ax squared plus bx plus c equals to 0. So this has got one variable, this has got two variables, right? So this is the one. Or you can use further writing it as 2x squared plus 5x say plus 20 equals to 0. This can be all form of a binomial equation. Okay, what is a trinomial equation? Trinomial equation which has got three variables, right? So three variable terms. So I can write trinomial as 3x cube plus 12x squared minus 8x minus 10 equals to 0. This is a typical example of a trinomial equation. What is this next one is that what is a linear polynomial equation? Something which has got a power of 1. So I can write a linear polynomial equation as x plus 2. I can use y plus 7, anything that we wish. What is a quadratic polynomial equation which has got a power of 2? So we can write a quadratic polynomial equation as 2x squared plus 5. This can be. It can be x squared plus 7x. It can be anything. It can be 5x squared plus 2x plus 11. This is also a quadratic polynomial equation. Finally, what is a cubic polynomial equation? Something which has got a power of 3. So I can write it as 8x3, or I can write it as 2x cubed plus x plus 1. I can write it as anything, like I can write 6 minus x cube, I can write 7 minus x cube, 7 plus x cube, anything. So these are just a kind of an overview to understand polynomial equations are monomial, binomial, which has got power 2, trinomial, right, which has got power 3, linear polynomial, power 1, quadratic polynomial, power 2, and cubic polynomial, which is power 3. Just to give you a basic idea on what is and what are the different types of polynomial equation. Now, if I come back again to our original definition, so polynomial equation. So this is what is a polynomial equation. So if I come back here, what I can show you is that a polynomial equation, what does it consist of? Okay, let me write it for a different pen with you. So polynomial equation. So here is my polynomial equation. So what it consists of? Let me see. So a polynomial equation. Okay. What are the things that it covers up? What are the things that it covers up? First one which you need to remember is a variable. Variable or variables, whatever. It can be variables. Number 2, it should have a coefficient. It should have a coefficient. Right? What it would also include? It would include operations like plus, it can be minus, and it can be multiplication. Note that it should not have division. It should not have division. It can be plus, minus, or multiplication. And lastly, it should also have what is in mathematical term what is called a non-negative integral exponent. It should have a non-linear integral exponent. That means it has to be raised to the power which has got a positive power. It won't allow anything negative. So if I take variable, if say for example, if I take I will omit this, is quite a long equation. So what I will do, I will just write a simple equation like 2x plus 3y equals to 0. Right? It has got variable. Yes, it has got variable. It has got coefficient. Yes, it has got coefficient. It has got an operation plus minus. Yes, it has got plus. Now it has got an exponent. Yes, it has got an exponent, which is when there is no exponent, we know it is called 1. Right? Now, for example, what I can do is that using this equation, so 2x plus 3y equals to 0, if I write 2x to the power inverse 1, is this is going to be a polynomial? No, it's a cross. Why? Because it has to have a non-negative integral exponent. This is a negative internal exponent. Let me give you another example. If I make 2 root x, is this considered to be a polynomial? No, this is not considered to be a polynomial because root has to be avoided, right? Okay, let me give you another example. 2x plus 3y by x. Is this a polynomial? No. Why? Because see, plus, minus and multiplication. Division should not be there. So it is considered to be it is not considered to be a polynomial equation. Now, that means what I can do is that I can put 2x to the power 2 minus 3y to the power 3, or I put 3 to the power 2. So if this is a positive one, which is called a non-negative integral component, then it is called to be a polynomial. So differential equation should be a polynomial derivative. So in order to understand what is a degree, which I told you, so let us now look quickly into the definition, what is called a degree. So a degree, a differential equation is polynomial in derivative, and the derivative, the exponent power of the highest order of a derivative is called a degree of a differential equation. Okay, we will come to this. So the most important part is that it has to be a polynomial derivative. Note this one. Differentiation is polynomial derivative. Then only we can find out a degree of a differential equation. In order to be a polynomial derivative, it has to satisfy these 4 rules: variable, coefficient, plus, minus, and subtraction, non-negative integral exponent. And there are certain other things that it should also should not have a kind of a trigonometric function. I will just show you and then you can understand. So I'll just quickly give you certain examples so that you can understand what it is. So what we are going to do is that when we are trying to find out whether it is a polynomial derivative or not, we are going to treat dy by dx as a variable. So we are going to treat dy by dx as a variable. Now let me give you an example. So dy by dx, I can plug in square, plus, minus, anything. Now for example, I give you the first instance, dy by dx, and I make plus sine of dy by dx equals to 0. Right? Okay. So we are going to find what? We are going to find whether it is a polynomial derivative or not. Polynomial derivative. Okay. Polynomial in derivative. So I can take it as PID. So just watch. Variable, coefficient, plus, minus, multiplication, non-negative. But what it does, let's show you in red or maybe in blue. Doesn't matter. So what it does, it shows a sign. That means it is using a trigonometric function. That means it is not a polynomial in derivative. I use this one as polynomial in derivative, right? Now what I do is that let me give you another example. The more examples we do, we will find it out easier. So dy by dx plus I use sine inverse of dy by dx equals to 0, right? Again, we have got this sine inverse one. That means it is not a polynomial in derivative. It cannot have a sine. Okay, let us see this one. Dy by dx plus log of dy by dx equals to 0. Is this a polynomial derivative? No. This is also not a polynomial in derivative because it has got this log sign. So sine, tan, trigonometric function, logarithm, this cannot be done. Right? Okay. So we get another example. We can write it this one. Say for example, dy by dx plus cos of x equals to 0. Now, is this a polynomial derivative? You can pause the video and think and let me know. Yes, this is a polynomial derivative. Now, you might be wondering that if I have denied sine and log over here, how I am saying that this is a cos x is going to be a polynomial derivative. Now, you see what is the definition. A differential equation is polynomial in derivative. The exponential power of the highest order derivative is called the degree of a differential equation. That means if I am treating dy by dx as a variable, then cos of dy by dx would not have been a PID or a polynomial derivative. But here I am taking this as a variable. This as a variable. So definitely yes, this is a polynomial in derivative. Clear? I think that makes sense. Right. So dy, what you need to know is that if I write dy by dx, okay, plus sine of inverse x equals to 0. Is this a polynomial derivative? Yes. This is also a polynomial derivative because the sine inverse is acting on the variable x, not on the derivative, that is dy by dx. Would it have been the case that dy by dx plus sine of dy by dx equals to 0? That we have seen it over here, it's the inverse. Then it would have not been a polynomial in derivative. Right. So what we do summarize from here is that what it would include. Okay, what are the inclusions? Let us see. So what it would include? Let me write it. Include. So this would include first of all plus, right? It would include minus, and it would include multiplication, and it would include something which is called a positive. So the power must be positive. So it would, and what it would not include, let me write it for you. What it would not include. So it would not include those things like sine dy by dx would not include, sine inverse of dy by dx it won't include, it won't include log dy by dx, it won't include, right? It would also not include exponential of dy by dx. This would also not include, and it would also not include root of dy by dx. But mind it that in certain cases we try to eliminate that root. If you are eliminating that root, then it is absolutely fine. Then it is absolutely fine. So this is basically what is called the summary. And more or less what are the things that it would include and it would not include, right? So okay, so let me show you the last few examples. So if I take a kind of a equation, it is a little bit longer, so let me show it for you. So x, I write d2y by dx2 plus I use this term d10y by dx raised to the power 10, clear, plus I would use dy by dx, right, plus sine of dy by dx equals to 0. So what is the degree? So the degree is nothing because this would not happen. It is a trigonometric function. Provided that we would have changed this to sine of x equals to 0, right? So what we are going to do is what is the highest. First of all, we have seen that this is a polynomial equation. Yes, it is a polynomial derivative. What is the highest? This is the highest one is d10. I'm so sorry. This would be raised to the power 5, right? This is raised to the power 5 and this is raised to the power 3. And this is raised to the power 1. Anyway, I need to write it. So if is the highest derivative is 10, what is the power? Power is 5. So the degree here would be 5. I will just quickly show you a few examples and that would conclude that part. So I will just show you a few examples in order to understand that how you will understand the degree. So the first condition that you need to understand is that yes, it has to be a polynomial in derivative. In order to be a polynomial in derivative, in order to be a polynomial in derivative, what are the things that you need to have? First of all, you need to understand what is a polynomial that we have seen. And we also have to understand that it would not include sine or cosine or any trigonometric function or an exponential root or sine inverse or anything. And it would include plus, minus, subtraction and a non-negative integral. That means the power should be positive. Let me show you a few examples. Things will become much clearer and you will yourself be able to find out. So first of all, let me show you d2y by dx2, right, plus 3x, and we have got dy by dx raised to the power 2 equals to 0, right? First of all, is this a polynomial derivative? It has got plus, minus. It has not got any those things like it has not got sine, cos, log, etc. So yes, first one, yes, it is a polynomial in derivative. That is true, right? So what is the highest power raised? This one. So the highest derivative is d21. So what is the power? Power is 1. So that means degree is 1. Clear? Degree is 1. Now, let me show you another example. So, d2y divided by dx2, and I have got plus a, right? dy by dx equals to 0, right? So, what is this a? In general, in calculus, this is basically a constant. This is called as a constant. Is this a polynomial in derivative? Is this a polynomial in derivative? Yes, it is a polynomial derivative. Certainly, because it has not got those signs. And what is the highest power is? This one. So what is the degree? To the power 1. So the degree is 1. Okay. Now let us see another example. We get, let me write it in this way. D raised to the power minus 2y by dx whole squared plus 5 dy by dx. First of all, you need to understand, is it a polynomial in derivative? No. Why? Because this sign. Because of this sign, anything raised to the power inverse minus 2. So this is something which is a symbol which shows that it is not a polynomial derivative. So what would be the degree? Degree will be undefined. Degree is undefined. Let me show you another example. Things will become clear. We get dy by dx raised to the power minus 2 plus 5 dy by dx equals to 0. This one. Okay. Obviously, this won't be because this has got an inverse. So again, the degree will be undefined. Clear? Let me show you with the prime notation. So y1, 2, 3 squared, right? Plus y1, 2, that means second order, right? Cube plus y prime 4 plus y5 equals to 0. Right? Is this a PID? Is this a polynomial in derivative? Definitely it is a polynomial in derivative because it is quite clear it has not got those signs. So what is the degree? So this is the highest derivative 1, 2, 3. What is the degree? What is the power raised to 2? So the degree would be 2. Degree would be 2. Now let us take the last example. Say for example I take y prime triple prime plus y squared plus e raised to the power y. Is this a polynomial in derivative? First of all, no. No, it is not a polynomial in derivative. Why? Because you cannot take an exponential, right? We have seen this in your previous example. So, what is the degree? Degree is undefined. Degree is undefined, right? So, what are the things, again to revise, what are the things you should not include? So, one would be the trigonometric functions, sine, cos, tan, right? And inverse, or you can also take inverse trigonometric functions. Log you cannot take, exponential we cannot take, and the derivative, whatever the derivative is, the power should be positive. So these are the things which are cleared out, that in order to find out a degree of a of an ordinary differential equation, first of all you need to find out that whether that particular form is a polynomial or not. So the degree of a differential equation, here I will just quickly revise. Differential equation must be a polynomial. We have seen what is a polynomial equation, different types of polynomial equation. We have seen that. We have seen that polynomial equation should have a variable plus, minus and subtraction, plus, minus and multiplication, and it should be non-zero, right? So you can put up anything. It can be plus 3 dot dot anything. You can change it to minus, you can change it, but you cannot change it to division. This is prohibited. Clear? Non-negative integral exponent means that you cannot raise anything to the power of n. This won't be allowed. Clear? So these are all examples which shows that these are not polynomial equations. Clear? So that is how we find out. And here are the examples which I have sorted out for you. Dy by dx of sine you cannot have, log you cannot have, but note that you can have log or cos, but not of the derivative, but you have a variable x. It can be cos, it can be tan, it can be tan inverse, it can be anything, but it should not be, the trigonometric function should not be of the derivative. So finally here we arrive, include is plus, minus and is a positive. Not includes are the sine, log, any trigonometric function, and exponential and the root. But mind it, that root might get swiped off. So that is how we do. So that is all what we wanted to know, that how we can know the degree of a differential equation. These are the levels and the different examples which we have sorted out. I hope you liked it, because order is quite simple. Anybody would be able to tell it. But degree, you need to find out whether it is a polynomial in derivative, whether it is a polynomial or not, and if it is a polynomial, whether it satisfies 1, 2, 3, 4, all those steps we have shown. And then what you need to do is quite simple. All you need to do is that you need to find out the highest order, the power, and then you can find out the order. So if these are things like this we have shown, you got this one and raised to the power. So these are all examples in which you can find out the order, and these are the examples in which you can find out the degrees. So degrees are now, I think how to find out the degree is quite clear, and you need to be very cautious in finding out all those values, because without that it is almost next to impossible, because degree cannot be found out. These are the last few examples which I will like to show you on the screen. So this is how you find out the degree. If it is not a PID, then the degree is undefined. Here you see you need to find out this, the highest derivative, and then you find out the power. You need to find the highest derivative and you need to find them. Provided this would have not been minus 2, then it would have been again what? 1, because this is raised to the power 1. This is also the simple case. The highest power is d2 and raised to the power 1. These are the examples in which you can find out the derivative. Thank you very much for watching this. It has been 3 long videos which clears out the basics concepts of differential equation. In my next video, what we are going to do is that we are going to look forward with the basic formulas of differential equation, the chain rule, the quotient rule, and various other rules. We are going to take simple examples. I hope you like it. So just you can subscribe, like, and share. Thank you very much for watching this video. Stay safe and stay happy. Bye.